Every single thing made of steel around you, your car, your fridge, the bridge you crossed this morning, the skyscraper cutting through the clouds, none of it started as steel. It started as dirt, deep underground, buried in rock, locked inside mountains, raw iron ore, reddish, crumbly, completely useless on its own. But somewhere, right now, in a facility the size of multiple football fields, that dirt is being fed into a machine that runs at nearly 3,000 degrees Fahrenheit, hotter than volcanic lava. And what comes out the other end? The most important material in human civilization. This is the story of what happens inside a blast furnace, a process so extreme, so precise, so brutally powerful that most people have no idea it's happening every single minute of every single day. Let's go inside. It starts underground. Iron ore, mostly in the form of hematite or magnetite, is extracted from open-pit mines across Australia, Brazil, and Canada. Some of these mines are so massive, you can see them from space. But here's the problem: raw iron ore isn't pure iron. It's iron mixed with oxygen, silicon, rock, and all kinds of impurities. You can't build a car with that. You can't make a bridge with that. So before a single piece of ore ever reaches a steel mill, it goes through a preparation stage called sintering or pelletizing. The ore is crushed into fine powder, then rolled into small pellets about the size of marbles and baked in a kiln at around 200–300 degrees F. This makes them hard, porous, and ready to handle the extreme heat that's coming. These pellets are then mixed with coke, not the drink, not coal, but a specially processed form of carbon fuel made by baking coal at extreme temperatures until it becomes almost pure carbon. Think of coke as the fuel and the chemical agent that drives this entire process. The third ingredient, limestone, ordinary limestone pulled from quarries, its job to grab all the garbage, the impurities, the rock, the sand, and carry them away as waste. We'll come back to that. 3 ingredients: iron ore pellets, coke, limestone. Together, they're about to go into one of the most violent industrial environments on Earth. A blast furnace looks like an industrial tower, typically 100 to 130 feet tall, wrapped in steel casing, lined inside with heat-resistant brick called refractory lining that can withstand temperatures no human could survive within 50 feet of. And here's the thing: once a blast furnace is turned on, it doesn't stop. Not for holidays, not for weekends, not for years. Some blast furnaces run continuously for 10 to 15 years before they're shut down for maintenance. Turning it off and restarting is so expensive and damaging, it's almost never done unless absolutely necessary. The raw materials, ore pellets, coke, limestone, are loaded from the top through a sealed charging system. Layer by layer, alternating, coke, then ore and limestone, then coke again. The furnace eats continuously, like a machine that's always hungry. Now here's where it gets brutal. At the base of the furnace, massive pipes called tires blast preheated air heated to over 2,000 degrees F directly into the lower chamber. This superheated air reacts with the coke and creates temperatures near 3,000 degrees F at the core. At that temperature, the coke doesn't just burn, it combusts and produces carbon monoxide gas. And that gas rises through the furnace, reacting chemically with the iron ore as it descends. The oxygen is stripped away from the iron atoms, a process called reduction, and liquid iron begins to form. Meanwhile, the limestone is doing its job. It breaks down into calcium oxide, which reacts with the silica and rock impurities, forming a liquid waste material called slag. Slag floats on top of the liquid iron because it's lighter. 2 separate liquids forming, layer by layer, in absolute silence from the outside. Inside, pure chaos. Every 4 to 6 hours, workers at the base of the furnace approach what's called the tap hole, a sealed opening in the furnace wall, plugged with a clay-like material. They use a pneumatic drill, a mud gun, to blast open the tap hole. And then it happens. Liquid iron, glowing orange-white at 2,700 degrees F, pours out in a river of molten metal, flowing down channels called runners into massive torpedo-shaped ladles. These ladles hold up to 300 tons of liquid iron at a time. The slag, being lighter, is tapped from a separate hole above it and directed away to be cooled, crushed, and repurposed as road construction material or cement additive. Nothing is wasted. The liquid iron at this stage is called hot metal or pig iron. It contains about 4 to 5% carbon, along with traces of silicon, sulfur, and phosphorus. And here's the critical thing: this is not yet steel. Pig iron is hard, but extremely brittle. Drop a piece and it shatters. You cannot shape it. You cannot weld it. You cannot build anything meaningful with it. It has too much carbon, too many impurities. To become steel, it needs one more transformation. The torpedo ladle of liquid pig iron is transporting, still at 500 degrees F, to the next stage, the basic oxygen furnace, or BOF. The ladle tilts, and the molten pig iron, all 300 tons of it, pours into a giant vessel shaped like a massive barrel, lined with more refractory brick. Then a water-cooled lance drops from above, hovering just feet above the surface of the liquid metal. And it fires. Pure oxygen at supersonic speeds blasts into the molten iron. The reaction is violent. The furnace glows, flames shoot up, the temperature inside spikes. Carbon burns off as carbon dioxide gas, impurities oxidize and rise to the surface. In just 20 minutes, the entire chemistry of the metal changes. Carbon content drops from 4–5% down to less than 1%, sometimes as low as 0.02%, depending on the grade of steel being made. Sulfur, phosphorus, silicon, all removed or reduced. What's left is steel, still liquid, glowing, molten, but chemically transformed. From here, precise amounts of alloying elements are added depending on what the steel is meant for. A little manganese for strength, some chromium for rust resistance, nickel for toughness. Every recipe is different. Then the liquid steel is poured into a continuous casting machine, where it flows through a mold, gets cooled with water jets, and solidifies into solid slabs, billets, or blooms, the basic shapes that will be rolled, cut, and shipped to factories across the world. The world produces roughly 1.9 billion tons of steel every year. That's more than 5 million tons every single day. Every skyscraper you've ever stood beneath, every car you've driven, every ship crossing the Pacific, every surgical tool in a hospital, every rail line running through a continent. All of it came from the same journey: iron ore pulled from the ground, fired to temperatures no living thing can survive, chemically stripped of its impurities, and reborn as something strong enough to shape civilization. Inside a blast furnace, the Earth's raw material goes through one of the most intense, most precise, most brutally engineered transformations in all of human industry. And most people never know it's happening. Now you do.